In 12th century Baghdad, builders started carving a wooden screen, so dense they looked like lace. And for the next 800 years, across Cairo, Jeddah, and the cities of Persia, these carved screens became one of the most sophisticated pieces of climate control tech a house could have. It shaded the room, cooled water, and dropped the indoor temperature by as much as 12 degrees Fahrenheit, and it did all of it with no electricity, no moving parts, and no power source beyond the environment's natural properties. But even now, engineers measuring these ancient screens are finding numbers a modern shading system struggles to match. This is called a mashrabiya, and it's a masterclass in passive cooling. But what is it actually doing? And why, despite nearly a century of proven usage, are these still not widely used across the Western world? Let's find out. The regular glass in your home is almost perfectly transparent to sunlight, which sounds like the point of a window, except that visible light isn't the only thing coming through. Just under half of the sun's energy arrives as near infrared, and clear glass lets it pour straight through as easily as daylight. That heat lands inside, soaks into your floor and walls and furniture, and those surfaces warm up and radiate it back out. But now it's changed form. It leaves as long-wave infrared, a slower, lower kind of heat that can't escape back out through glass the way it came in. That's the greenhouse effect, and it's the same reason a parked car becomes an oven while the air outside stays merely warm. In Phoenix or Riyadh, an unshaded pane of double glazing can pour nearly 9 kilowatts of heat into a single ordinary room every hour, a load your air conditioner is desperately trying to fight. But long before mechanical cooling systems, the Persians created their own system for cooling interior spaces. The mashrabiya, in the form we'd recognize, shows up in 12th century Baghdad, and the name is beautifully literal. It comes from the Arabic for to drink. The projecting wooden box first held porous clay water jars in the path of the breeze, and air moving through the lattice evaporated a little water off the clay, so the jars and the room came out cooler. From Baghdad, it spread along the trade routes. In the Red Sea port of Jeddah, it grew into the Roshan, a tall, cantilevered window of imported teak, angled to catch the sea breeze and pull it indoors. In Iraq, it became the shanashal, jutting over narrow streets so neighboring houses shaded each other. It was, for centuries, simply how you built a house in a hot, bright place. Then, Persia, modern-day Iran, took the idea and did something different. Instead of a projecting box built to catch wind, Persian builders set a flat screen flush into the wall and called it an orosi, a tall sash facing a private courtyard rather than the street. The orosi traded some airflow for something the mashrabiya didn't have. Its lattice was filled with panes of tinted glass, offering protection from insects and cooler winters, while still offering some of the original benefits of the mashrabiya. The whole orosi was locked together from thousands of small wooden pieces with carved joints free of nails and glue, so it could expand and contract through desert heat and cold nights without tearing itself apart. The genius of the mashrabiya comes down to the multiple jobs it performs simultaneously. The first move is the most important. The screen blocks the sun before it reaches the glass. The carved wood is deep, not flat, so the lattice works like an egg crate. The thickness of each bar shadows the openings, catching the harsh, direct rays while still letting soft, diffused daylight through. The heat is absorbed on the outer face of the wood and shed back into the open air, so it never gets near the room. On the orosi, tinted glass adds a second filter, soaking up a quarter to a half of the visible sunlight while the room still glows. The second trick happens in the gaps. When air squeezes from the wide outdoors through a field of tiny openings, it speeds up, the same reason you get more spray by putting your thumb over a hose, and that fast jet shoots deep into the room. As it speeds up, its pressure drops, tugging the stale air already inside out through other openings. This is the Venturi effect, and it transforms a faint breeze into active ventilation, with no fan and no moving parts. The third trick is the one the name pays homage to. That fast air is often steered past wet surfaces, old water jars, or just a damp cloth at the inlet, and the dry desert air drinks the moisture up. Evaporation costs energy, and the only place to get it is the air itself, so as the water turns to vapor, it pulls heat straight out of the breeze. So the screen isn't one device. It's a shade, a fan, an evaporative cooler, and a heat valve in one piece of wood. A modern building needs multiple separate mechanical machines for those jobs. The mashrabiya does all four on nothing but the sun and the wind. So the mashrabiya is brilliantly simple, but it's also extremely effective. In a 2023 study published in the journal Sustainability, researchers modeled a residential villa in hot, arid Saudi Arabia. On July 15th, the hottest day of the year, the outside air hit nearly 101 degrees. The unshaded building pulled about 8.68 kilowatts of solar heat through its windows at the peak. But with the mashrabiya, it fell to 2.99, a 78% cut in peak solar gain. The indoor temperature also dropped by around 14%, and because the lattice spreads light rather than blocking it, the daylight in the room actually got better, not worse. Then in another independent study, a pair of researchers tested two identical west-facing rooms in Jeddah through the peak of August. The heavy walls held the indoor temperature to a swing of a few degrees, while the outdoor air lurched across nearly 30 degrees in a single day. They then hung a wet cloth at the inlet, switching on that evaporative trick, and the average room temperature fell by 12 degrees, holding the room near 92, while it was nearly 107 outside. And the impact that reduced heat gain can have on your energy bill is huge. A retrofit study in Al Ain found an optimized screen cut a real apartment's annual cooling energy by 12.3%, an eighth of the cost of cooling a modern home, with nothing more than a wooden screen. And results like that raise an obvious question. With such cooling and energy-cutting potential, you'd expect to see the mashrabiya everywhere. Yet every new building in Phoenix and Dubai is still a sealed glass box. The reason for that is there are a few realistic practicalities of incorporating mashrabiya in modern Western world dwellings. The biggest is climate, and it's a big one. That evaporative trick, the one that gets you the full 12-degree drop, only works when the air is dry enough to take on water. In a humid place like Florida, where summer air sits above 80% humidity, there's nowhere for the moisture to go, so an evaporative screen just makes the room muggier and invites mold. Then there's a safety rule that, in the United States, is the real killer. Building codes require that every bedroom have a window you can climb out of in a fire, openable from inside without a key or tool. A traditional mashrabiya is a fixed screen bolted across the outside of the window, which traps you in and blocks firefighters from getting to you. While easy modifications could be made, the way this system has been built for 1,000 years, it is flatly illegal in an American bedroom. While there are certainly some limitations to the mashrabiya, and their ancient form is a rare sight in the Western world, their influence has spread into modern architecture, serving as the inspiration of shaped facades found on many new buildings across the world. The Masdar city in Abu Dhabi is one such place where you can find the modern interpretation of the mashrabiya in action. Its clever facade helps reduces energy consumption by up to 55% compared to standard Abu Dhabi buildings. Then, there's mega projects like the Doha Tower that have incorporated this ancient architecture into its design. Around the entire facade is a 46-story cylinder in a fixed aluminum lattice, based on the mashrabiya. The pattern is woven to just 25% density on the cooler north face, 40% on the south, and a dense 60% on the brutal east and west sides that catch the low morning and evening sun. This clever design is estimated to reduce solar gain by over 50% and decrease the building's cooling loads by approximately 20%. But some modern buildings have taken the lessons of the mashrabiya one step further through the use of dynamic facades. The first attempt at a dynamic facade was in 1987 when architect Jean Nouvel wrapped the south face of the Arab World Institute in Paris in 240 metal screens, each one a grid of mechanical apertures built like the iris of a camera. Photosensors read the light, and the diaphragms opened and closed to hold the interior at a steady glow, throwing shifting geometric shadows across the floors as they moved, creating one of the most celebrated facades of the 20th century. More recently, the Bahr Towers, which were completed in 2012, wrapped the 25-story towers in over 2,000 of these screens, becoming the largest computerized dynamic facade in the world. Each unit is a star-like shade coated in reflective fiberglass, mounted on its own frame and standing about 6.5 feet off the glass. As the sun rises in the east, the screens on that face fold shut, and the closed band travels around the building through the day, opening again at night. Thanks to this extremely clever design, solar heat gain through the envelope is cut by more than half. And if you want to utilize some of the powerful benefits of the mashrabiya in your own home, you can. Although there are a few things you need to know. If you're building from scratch or doing a serious retrofit, there's a healthy commercial market for exterior shading, from imported Persian orosi sashes at roughly $600 to $900 a panel, to modern manufactured solar screens and fixed perforated panels. But before you order anything, always ensure you fully understand any restrictions set by your local building department or homeowners association. Because anything mounted on the outside of your windows counts as an exterior modification, it almost always triggers architectural review. And if window facades aren't an option in your neighborhood, then you'll likely need to embrace alternatives that offer partial benefits that a mashrabiya offers. To reduce infrared radiation into your home, a retractable awning is one of the best low-drama options going. On a south-facing window, it can knock back solar heat gain by up to 65%, and on a west-facing window up to 77%, and you can roll it away in winter when you actually want the sun. But if even that's too visible for your homeowners association, low emissivity glass or a low-E window film is the invisible fallback. A good film blocks a large share of infrared heat, can cut cooling costs by up to 30% in a hot climate, and can drop indoor temperatures by several degrees, all with no change to how the house looks from the street. While these solutions will help minimize heat gain, neither one gives you the airflow or the evaporative cooling that made the original Persian screen so special. And if you do get the green light for the real thing on a bedroom window, remember the rule that overrides everything else: the egress code. A fixed screen bolted across a bedroom window is illegal because it traps you in a fire and blocks firefighters from reaching you. The compliant version is a sliding exterior panel on a track, held shut by a spring-loaded latch with a release cable inside the room. Pull the handle, and the panel slides clear. That one detail is the difference between a code violation and a code-compliant retrofit. A mashrabiya is a sheet of carved wood that shades, ventilates, and cools all at once, drawn from a 1,000-year-old design that our sealed glass towers are only now circling back to. If you enjoyed this video and want to see another ancient design that helps cool modern buildings, then take a look at our video on the solar chimney next.